Exploring Life. Chapter 22, Ecology. Part 3. The biosphere is more than just the sum of Earth's biomes. It's a dynamic, interconnected system of all living organisms and their interactions with each other and the environment. From ocean depths to mountain peaks, it spans every ecosystem and actively shapes Earth's systems. Life influences climate, drives weather, and even alters geology, playing key roles in soil formation, nutrient cycling, and landform development. The biosphere is tightly linked to three major Earth systems. The atmosphere regulates temperature, blocks harmful radiation, and provides essential gases like oxygen and carbon dioxide. The lithosphere, Earth's solid outer layer, supporting life and supplying nutrients. The hydrosphere, all water on Earth, vital for aquatic ecosystems and water-dependent life. Together, these systems create a complex, interdependent network that makes Earth a living, dynamic planet. The biosphere functions as an open system for energy, receiving a continuous supply from the sun. Solar energy heats the planet and powers nearly all life on Earth. It drives photosynthesis, allowing producers, like plants and algae, to convert sunlight into chemical energy. That energy then moves through food chains, from herbivores to carnivores to decomposers. With each transfer, some energy is lost as heat, in line with the second law of thermodynamics. The amount of energy available at the base of the food chain ultimately limits the size and complexity of ecosystems. Because energy is not recycled, a steady input of solar energy is essential to keep ecosystems functioning, and to support the growth, reproduction, and survival of all living organisms. Unlike energy, which flows in and out, the biosphere operates as a closed system for many essential elements, such as carbon, nitrogen, and water. These elements are not used up or created anew. Instead, they cycle continuously between living organisms and the non-living environment. Plants absorb carbon dioxide from the atmosphere, animals consume plants and use the carbon in sugars, and decomposers return nutrients to the soil. Water evaporates, condenses, falls as precipitation, and flows through living systems. Nitrogen moves from the air to the soil to organisms and back again. These biogeochemical cycles make life on Earth sustainable, ensuring that the building blocks of life are reused over and over to support new growth, reproduction, and energy flow. Without this recycling, essential resources would quickly run out, and ecosystems would collapse. The biosphere doesn't just depend on the atmosphere, it also shapes it. Earth's current atmosphere, about 78% nitrogen and 21% oxygen, is largely the result of biological activity. Photosynthetic organisms like plants, algae, and cyanobacteria continuously produce oxygen. Without them, free oxygen would quickly vanish as it reacts with other elements. Oxygen is essential for aerobic life, however, at high levels, it becomes toxic. Nitrogen helps dilute oxygen, making it safe to breathe. Nitrogen gas, N2, has existed since early Earth, but its balance is regulated by the biosphere through the nitrogen cycle. Nitrogen-fixing bacteria and decomposers convert it into usable forms and return it to the atmosphere, keeping levels stable. By transforming the atmosphere, the biosphere has shaped the evolution of life, influencing how organisms get energy, survive, and form ecosystems. This schematic illustrates the nitrogen cycle. Nitrogen-fixing bacteria convert atmospheric nitrogen into usable compounds that plants can absorb. Through the food chain, nitrogen moves into animals and other organisms. When organisms die, decomposers return nitrogen to the soil, making it available to plants again. Some nitrogen is also cycled through non-living processes like lightning, volcanism, and atmospheric deposition, nitrogen falling from the air via rain or dust. However, human activities, such as synthetic fertilizer use and industrial emissions, can add excess nitrogen to ecosystems, disrupting the natural balance of the cycle. The biosphere plays a major role in regulating Earth's climate, largely through its interaction with greenhouse gases. Gases like carbon dioxide, methane, and nitrous oxide help trap heat in the atmosphere, creating a greenhouse effect that keeps Earth warm enough to support life. Without these gases, our planet would be too cold and inhospitable, but when levels rise too high, they can cause excessive warming and climate instability. Many of these gases are naturally produced by biological processes. Methane is released by microorganisms in wetlands, oceans, and even the digestive systems of some animals. Nitrous oxide comes from bacteria involved in nitrogen cycling, especially in soils. Carbon dioxide is produced during respiration, decomposition, and natural events like wildfires and volcanic eruptions. Through these processes, the biosphere helps maintain a delicate balance, one that stabilizes temperatures, supports weather patterns, and sustains life across the planet. The biosphere plays a major role in regulating Earth's climate, largely through its interaction with greenhouse gases. Gases like carbon dioxide, methane, and nitrous oxide help trap heat in the atmosphere, creating a greenhouse effect that keeps Earth warm enough to support life. Without these gases, our planet would be too cold and inhospitable, but when levels rise too high, they can cause excessive warming and climate instability. Many greenhouse gases are naturally produced by biological and geological processes. Methane is released by microorganisms in wetlands, oceans, and even the digestive systems of some animals. Nitrous oxide comes from bacteria involved in nitrogen cycling, especially in soils. Carbon dioxide is produced during respiration, decomposition, and natural events like wildfires. This diagram shows how carbon flows through Earth's major systems: the atmosphere, biosphere, hydrosphere, and geosphere. Carbon dioxide enters the atmosphere through natural processes like volcanoes and respiration, as well as human activities like burning fossil fuels. In the biosphere, plants absorb CO2 through photosynthesis and convert it into organic matter. As animals eat plants, carbon moves through food chains, and respiration releases CO2 back into the air. When organisms die, some carbon is added to the soil, eventually forming fossil fuels over millions of years. In the hydrosphere, atmospheric CO2 dissolves into water, affecting acidity and marine ecosystems. The carbon cycle depends on a delicate balance, with carbon constantly moving between living systems and the Earth itself. The biosphere plays a major role in regulating the planetary water cycle. It helps retain water in surface soils, reducing runoff and slowing erosion. It also promotes natural infiltration into underground aquifers and slows the flow of water into rivers and oceans, helping stabilize freshwater availability. Finally, the biosphere directly influences both humidity and precipitation. Through transpiration, plants release water vapor into the atmosphere, increasing humidity, forming clouds and driving rainfall. Without a healthy biosphere, the water cycle would function much less efficiently. Freshwater sources would become less stable and rainfall patterns could shift, becoming less frequent but more intense, with a greater risk of droughts, floods, and erosion over time. The biosphere and climate are deeply interconnected, each constantly influencing the other. Changes in climate, such as shifts in temperature, rainfall, or storm patterns, can dramatically affect the biosphere. These changes may alter species behavior, force shifts in geographic ranges, reduce biodiversity, and even drive evolutionary changes as organisms adapt, or fail to adapt, to new conditions. At the same time, the biosphere shapes the climate. Plants regulate carbon dioxide levels through photosynthesis, and organisms influence greenhouse gas emissions, cloud formation, and albedo, Earth's reflectivity. Understanding this two-way relationship is essential, not just for protecting ecosystems, but for managing global environmental health, climate stability, and the future of life on Earth. Important climate data comes from deep ice cores, like the one drilled at Vostok Station in East Antarctica. This core reaches over 3,000 meters deep and preserves a 420,000-year climate record. Tiny air bubbles trapped in the ice hold ancient gases, including carbon dioxide. By measuring CO2 in these bubbles, scientists can track changes in atmospheric carbon over time. To estimate past temperatures, researchers analyzed deuterium, a heavy hydrogen isotope preserved in the ice. Warmer periods leave more deuterium in snowfall, serving as a proxy for temperature. This evidence shows a strong link between CO2 levels and global temperature across glacial and interglacial cycles. The Vostok ice core reveals how rising CO2 correlates with warming, helping scientists understand past climates and today's human-driven changes. The biosphere doesn't just live on Earth's surface, it actively transforms it. One major influence is the role of oxygen, produced by photosynthetic organisms. High levels of atmospheric oxygen enable chemical reactions that wouldn't happen in a low-oxygen world. A key example is the formation of iron oxide, or rust, which gives soil and rocks their reddish-brown color. This happens when iron reacts with oxygen, forming minerals that alter the appearance and structure of Earth's crust. These reactions not only shape terrestrial landscapes, such as red soils and oxidized rock layers, but also influence the composition of oceans, contributing to changes in seawater chemistry over geological time. In short, the biosphere has helped sculpt the Earth itself, leaving lasting marks on the planet's geology, soils, and ocean systems. This is the structure of soil. The upper layer is made of decomposing organics, leaf litter and debris that naturally fertilize the topsoil. Beneath that is the subsoil, rich in minerals, but less fertile. And all of it rests on the bedrock that supports the landscape. When plants and animals fall, microorganisms rise, breaking them down into humus, the rich, dark matter that nourishes the future. In that quiet work beneath our feet, nutrients are cycled, water is stored, and the foundation of ecosystems is renewed to support new generations. To understand ecology is to recognize that all creatures are part of the same system, and that humans belong to the cycle, not apart from it. The future of life on Earth will be shaped by how well we remember this truth, and how wisely we care for the systems that sustain us. Now it's time to pause and reflect. Think back on the key concepts we've explored. Can you explain them in your own words? Take a moment to check your understanding, and notice what feels clear and what might need another look. This self-evaluation isn't a test, it's a chance to grow more confident before moving forward.